This YIJC differentiation question is a classic staple that every single J2 student must know how to solve before you go and sit for your A-levels this year. And let's take a look at how to solve this just as a recap on your implicit differentiation. So over here we have an equation where we are given x y square, so xy square minus 3x square y plus 144 equals to 0. And when we're asked to find the dy dx of this equation, it is a bit difficult to find because we have both x and y variables on the same side of the equation. So therefore, for this style of questions, we will just implicitly differentiate both sides. So when we want to shade with respect to x on both sides, we end up with the product law 2 times for these two, and that gives us x times, then we differentiate y squared, so we get 2y times dy dx, right? And then here will be 3, then after that we differentiate x squared times 2y, sorry, here we need to put a product law first, so we'll get y squared times 1, right? When we differentiate this using product law, and then when we differentiate this with product law over here, we essentially get x squared dy dx over here plus y times 2x over here, right? We need to differentiate implicitly, and then when we differentiate a constant, it becomes 0, so therefore we can just write that as 0. So over here we have 2xy times dy dx plus y squared minus 3x squared dy dx, and then over here we minus 6xy to give us 0. But then if we want to find dy dx, we need to make dy dx the subject, right? And therefore from here we just need to group all the dy dx terms together, so dy dx, and then over here we minus 3x squared dy dx, and all the non-dy dx terms we just need to bring to the other side. So you have 6xy minus y squared. Factorizing out the dy dx, we have 2xy minus 3x squared gives us 6xy minus y squared. And therefore our dy dx equation over here will just be 6x y minus y squared over 2xy minus 3x squared as the final answer to this question over here. Now, how do we find the coordinates of the turning point then? Right, you know that for a turning point, the dy dx is 0. So you can just say for all turning points, right, your dy dx is 0. So 6xy minus y squared over 2xy minus 3x squared equals to 0 has to imply that the numerator y squared equals to 0. And then from here you can factorize out the y to give us this, which means that y equals to 0, or 6x minus y equals to 0, which we can rewrite it as y equals to 6x over here, right? Now, how do we know which one to proceed with? This is where we need to be a little bit more careful and sub this back into the original equation. So remember, the original equation is xy squared minus 3x squared y plus 144 equals to 0. If let's say I sub y equals to 0 back into the original equation, I'll have x times 0 squared minus 3x squared times 0 plus 144 on the left hand side, and that will actually give me 144 on the left hand side, which is not the same as 0 on the right hand side, right? So there's a contradiction over here, and therefore we will reject y equals to 0, right? And then let's say we proceed with y equals to 6x, we sub it back to the original equation. We have x times 6x squared minus 3x squared times 6x plus 144 equals to 0, right? You expand this quadratic equation, you get 36x cubed, and then minus your 18x cubed plus 144 equals to 0, right? And when you solve this cubic equation, you end up with x equals to negative 2, and then when you sub x equals to negative 2 back inside this equation over here, you end up with y equals to negative 12, and therefore the coordinates of the turning point is minus 2 minus 12, which is the final answer to this very simple YIJC differentiation question. So this is a very staple differentiation question that I feel all J2 students need to know how to do. If you're still struggling with J2 math or even your statistics chapters, I have left with one more slot left at my math creation center before I officially close enrollment for all J2 students. So if you want to come and get tutored by me personally, make sure to WhatsApp the number on the screen over here to be my last student that I'll take in for J2 for the time being. And with that said, I look forward to seeing you on WhatsApp, and I hope that this video was helpful.